we're going to look at, excuse me, probability techniques. So remember that the experimental probability is different from theoretical probability. Experimental probability is determined by finding the probability based on trials of an experiment or collected data. So you actually do something to see what happens. The theoretical probability, however, is when you take your knowledge of an event and you look at all the possible outcomes of that event and you figure out or you determine the probability of it. So you don't actually do an experiment. When you're doing an experiment, as the number of trials increases, the experimental probability gets closer to the theoretical probability. So that means the more times you do an experiment, the closer you're going to get to the theory of an event. So I know there's a 1 in 2 chance of tossing a head when I toss a coin. The more times I throw a coin, the more likely I am to get closer to a 50%, which is a 1 in 2 chance of that event happening. So the more trials you do, the more experimental, the closer you get to the theoretical probability. All right, to calculate the theoretical probability in more complex problems, so let me fill that in here, we'll often use a tree diagram. So the theoretical probability we were looking at, tossing coins, cards, most of us can figure those out by thinking about the possible outcomes. There are sometimes more complicated events and we need to actually write them all down, kind of like I did when we were doing the sum of 3 and 11. I wrote out all the possible outcomes. So we can do that in something called a tree diagram as well. Another thing that gets used as we get into more complex theoretical probability is something called a complement. The complement of an event is the chance that the event does not occur. Oh wait, I better read my sentence here. Complement of event is the event not occurring. Yeah. Using probability, P stands for probability. So the probability event A occurs is the same as taking our perfect probability of 1 and subtracting its opposite, the event not occurring. And both of those are true. If something doesn't happen, it's the same as taking the perfect probability of 1 and subtract what does happen. So if I want to know the probability of tails, I could take 1 minus the probability of heads happening to figure out. That is how you would use a complement to figure out theoretical probability. So we're going to look at a little more complex example. What is the probability that when you flip a coin 3 times, heads will come up twice? So it's not quite as straightforward as what we were doing before, just whether I have heads or tails. So a tree diagram happens when I do something like this. I know that the first time I flip my coin, I will get either a head or a tail. And then if I get a head, I'll flip it again. And I'll either get a head or a tail. If I got a tail, I would flip the coin again as well. And I would also either get a head or a tail. So on my second flip, that's what could happen. I could get a head or tail to go with the head I got in the first flip, or I could get a head or a tail to go with the tail I got in the first flip. And the same thing will follow if I flip the coins for a third time. Well, to go with the head, if I got that, it could be a head or a tail. To go with the tail, it could be a head or a tail. And the same thing follows all the way down my little tree chart. So I want to know in this question, what's the probability when I flip a coin 3 times? So there's my possible outcomes. If I flip a coin 3 times, there's 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Those are the total number of outcomes I could get following my tree diagram. I want to know, should I have at least 2 heads? So if I got heads here, and then tails, that's what I'm looking for. Will come up 2 times. So I've got 2 heads in that scenario. Another place I would get 2 heads would be tails, heads, heads. There's another one. Tails, heads, heads. And where's another one? Oh, here we go. Tails, heads. Oh, I'm wrong. Whoops. Let's erase that. I circled the wrong ones. Heads, tails, heads. There we go. And I think that's the only path I can follow to get 2 heads when I roll the dice 3 times. So I have 3 possible pathways or events out of 8 total outcomes. So there's 3 ways that the probability of getting 2 heads will happen. 3 ways out of 8. So you can see it gets slightly more complicated. If we look at another one, what is the probability that when you flip a coin 3 times, heads will come up at least once? So this time, I want to know the probability of at least 1 head showing up on the coin. That means there could be 1 or 2 or 3. That's a lot of options to look at in my tree diagram. Sometimes instead of looking for so many options, it's easier to look at the opposite and do the perfect 1 minus the probability of no heads. And that's where we'd use our complement to figure out what we actually want to know. There's so many options where there's at least 1 head, it's easier to look for where I don't get any heads tossed at all. So if I look where there's no heads tossed at all, well, tails, tails, tails. And in fact, that's the only event where I get all tails, the only outcome where I get all tails. So I would have 1, and there's only 1 possible way to get no heads out of 8 total outcomes. So 1 whole take away 1/8 is 7 out of 8. So the probability of at least getting 1 head is 7 in 8. So fairly good odds, which should make sense. All right, let me slide. Oops, put the marker down. Put this up a little bit closer. All right, what is the probability when you roll 2 dice? You do not get a sum of 2 or 11. So I do not want 2 or 11. Well, if I think of my dice, I made that little table the other day. 2, 3, 4, 5, 6 for one of them. 1, 2, 3, 4, 5, 6. And I'm going to quickly draw that table again. So we're going to look at what the dice add up to, all our possible outcomes. And we looked at this with theoretical probability. There's all kinds of patterns in this table, by the way. Okay, there's my possibility. So not a 2 or 11, that's a lot of options when I look at the table and my outcomes. So it might be easier to take 1. I'm not sure why my board just made my 1 look like a 7. It might be easier to take 1 and subtract the probability of getting a 2 or an 11 because there are less of those events. Because there's 1, 2, and there's only 2 11s. So there's only 3 out of a total outcome of 36 to look at. which would give me 36 minus 3, 33 out of 36, which is an 11 and 12 probability of not getting a 2 or an 11. So quite a bit, quite high the probability. Slide that up. All right, what's the probability when you roll 2 dice, you get a sum between 4 and 10? So that means if I want it between 4 and 10, I'm looking at 5, 6, 7, 8, 9, and 10. I want to know when I get all those numbers, which is really the probability of 5 plus the probability of 6 plus the probability of 7 plus the probability, I missed my plus sign. Oh dear, I just messed that up entirely. Let's fix that. Plus the probability of 8 plus the probability of 9. You've got the idea. And if I look at my board, well, 5. There's my 5. 1, 2, 3, 4. Huh, would you look at that? So there's 4 times out of 36 that there's a 5. All right, let's look at the 6s. 1, 2, 3, 4, 5. Would you look at that? Huh, starts at the 5, and there's 5 events of 6 out of 36. 7. I'm going to make a prediction, but I'm pretty sure there's 6. 1, 2, 3, 4. Oh, look at that. 6. And 7. Wait a minute. Yeah, I just did 7. Sorry, 8. Oh, we're coming back down. 3, 5 out of 36. And 9. Huh, 4 out of 36. So if I add those all up nicely together, I'm going to get the probability of rolling a number between 4 and 10. 5, 6, 7, 8, 9. Oh, I just realized I shouldn't have 10 there. Sorry, guys. Looked at my own answer and I should have 9 there. Those are the numbers between 4 and 10. All right, so I'm going to go back and I'm going to add these all up. 4 and 5 is 9, and 6 is 15. 5 is 20, and 4 is 24 out of a total outcomes of 36. And that would reduce, both of them divide by 12, to a 2 in 3 chance of rolling a 5, 6, 7, 8, or 9. So these are a little more complex to figure out than the ones we've been doing previously. Take your time, draw yourself a picture if you need to. Draw it out, look at the possible outcomes compared to the total outcomes, and try the questions below.